Okay, let us talk about even and odd function. A function is even function if f of negative x equals f of x for all x in its domain. So, what happens is, if there is a formula, when we replace x by negative x in the formula, there is no change. The formula does not change even if we replace x by negative x. That kind of formula gives us even function. Those kind of functions whose formula does not change by replacing x by negative x, they are called even function. And if we think graphically, the graph of even function looks even function are symmetric about y axis. Well, I will show you a graph of even function. This is a graph of even function. See, the graph is symmetric about y axis. Symmetric means whatever we see on the left of y axis, we see the same thing on the right of y axis. Probably my face is also symmetric around y axis. Looks like I am an even function. Okay. Now, a function is odd function if f of x, f of negative x equals negative of f of x. If f of negative x equals negative of f of x, if the negative sign just comes outside, that kind of functions are called odd function. Graphically, the graph of odd functions are symmetric about origin. Symmetric about origin means whatever we see on the right up, the same thing we should see on the left down, or whatever we see on the left up, we should see same thing on the right down. For example, this is a graph which is symmetric, maybe not. Okay, I will show you a graph which is symmetric about y axis. None of this graph are symmetric about y axis. No, it is not. Okay. Let us look at one example of a graph, or one example of a even function and one example of odd function. So, let us see examples. Okay, let me take one formula and we will think of the graph. Let us think of this example, f of x equals x to the squared. If this is the given function, okay, suppose this is a given function, I want to know this function is a even function or odd function or neither. In order for me to know this is even or not, what I have to do is I have to replace x by negative x in the formula. So, I would say f of minus x, and I will replace x by negative x in the formula to get negative x squared. Negative x squared means negative x times negative x, that gives us exactly x squared. Negative x times negative x is x squared, negative times negative is positive. Look, even after replacing x by minus x, there is no change in the formula of the function. It is still the same formula as we started. So, this is an example of even function. This is an example of even function. Now, if we graph this function, recall that in order to graph this function, we can make a list of x and f of x. We can make a table. For example, let us say x is minus 2, minus 1, 0, 1 and 2. For x equal to minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square is 1 and 4. So, if I want to sketch the graph of this function, the graph should be looking like this. Let us say this is minus 2, this is minus 1, this is 1, this is 2. Now, for x equal to minus 2, y is 4. So, I will get this point. X equal to minus 1, y is 1. So, I will get this point. Let us say this is 1, this is 2, this is 3 and this is 4. So, I will get this. Now, x is 1, x is 0, y is 0, so I will get this point, x is 1, y is 1, so I will get this point, x is 2, y is 4, I will get this point. If I join this point with a smooth curve, this is what the graph will look like. See, this graph is symmetric about y axis. Whatever you see on the left of y axis, you see the same thing on the right of y axis. So, this is an example of even function. Okay. Now, let us look at example of odd function. Okay, let us look at another example. Let us say f of x equals just x. If I replace x by minus x, if I replace x by minus x, I will get minus x. See, when I replaced x by minus x, the only change I see is there is a minus. I can in fact replace minus x by minus fx, f of x equal to x. So, what happened is when I replaced x by minus x, a minus sign came out of the formula of the function, or replacing x by minus x, there is just a sign change, just a change in sign in the original function. If this happens for any function, we call it a odd function. So, this is odd function. Graphically, if we want to graph this function, let us say x and f of x, let us make a table minus 2, minus 1, 0, 1, 2, let us say. If x is minus 2, y, f of x is also minus 2, x is minus 1, this is minus 1, 0, 0, 1 and 2. This is what the table will look like. And if we want to graph it, let us say this is minus 2, minus 1, this is 0, 1 and 2. Let us say this is well, minus 2, so I have to go down, minus 1, minus 2, minus 3, 1, 2, 3, something like this. When x is minus 1, x is minus 2, y is minus 2, so we will get a point here. X is minus 1, y is minus 1, we will get another point here. X is 0, y is 0, we will get a point here. X is 1, y is 1, we will get another point here. X is 2, y is 2, we will get another point here. If we connect this, by the way, this is a straight line, by the way. Now, for this straight line, see, whatever we have on the right up, on the right up, the same thing is on the left below. So, this graph is symmetric about the origin. If any graph is symmetric about origin, that represents an odd function. So, this is the graph of odd function, this is a graph of even function, this is a graph of even function, this is graph of neither. This graph is neither symmetric about y axis, because whatever we have on the left of y is not the same in the right of y, and whatever is in the on up from origin here is not the same as origin here, and whatever is in this quadrant is not the same thing in this quadrant. So, this is neither symmetric about origin nor symmetric about y axis, neither an odd function nor even function. Well, in terms of formula, let us say there is a formula like this, f of x equals x plus 5, very simple function, x plus 5. If I want to know this is even or odd function, I will replace x by minus x. So, f of minus x equal to minus x plus 5. See, the formula is not same, number 1. Number 2, this is not even equal to negative of f of x. By negative of f of x, we should get negative of x, negative of 5. Sign of both the things should change. But if we see here, sign of x is changed, sign of 5 does not change. So, this function, when I replace x by minus x, this is neither equal to negative of f of x nor equal to, this is not also equal to the function itself. So, this is neither equal to the function itself nor equal to the negative of the function. That means, this is an example of neither odd nor even. So, the basic idea is a function can be even function, can be odd function, can be none. In order to identify it is even or odd or neither, with the help of formula we will need to replace x by minus x in the formula and see what happens in the output. If a graph of a function is given to us and we want to know it is even or odd, we need to see either it is symmetric about x axis or it is symmetric about origin or it is not.